Can you see my screen?
Yes, teacher.
Yes, sir.
Okay. If you remember, I talked about the general capacity of soil. To you, if you remember, we had, for example, based on tertiary matter, we have one, for example, for square foundation, 1.3 C prime MC plus Q NQ plus zero point 0.4 gamma B and gamma. I told you that each term belongs to each property of soil. This was for this was for this one was for cohesion. This one was for uh, the weight of the soil above the level of the bottom level of the foundation, and this one was for the soil below the foundation. One of the things, and I told you that we have two ways of obtain NC, NQ, and N gamma. One of them is using uh, their formulations, and the other one is using tables. And I told you that it's obvious that using tables is much more easier than calculating them by our own. So this is the general formulation. But uh, as I said, this is the foundation, and this is the soil. In a couple of cases, we cover the columns or we cover the foundation by soil. But in the other cases, we may uh, leave this area empty. But the thing that is important is the situ or the condition of the soil here. If you remember, I told you that we have term gamma in here and Q, and depends on the situation of the soil. We have different Q and different gamma, okay, or even different cohesions. But for now, we're talking about uh, the level of the water. Okay, the level of the water. We show the level of the water using this symbol. The water can be in different levels. For example, the water can be here. The water can be here. The water can be here. So it depends on these levels. We'll have different uh, behaviors, and for each behavior, we have to find uh, the capacity. In this case, we assume three different levels. So the first one, I'm gonna write it here. This is our foundation. This is the ground level. What's this? BF and B. Okay. In the first case, Here we show the water level with D. Okay, this is the water level. In the first case scenario, the distance from the surface of the ground and the water level is D, and D is between 0 and D. Okay, to find, uh, as I said, um, the Q term and gamma term uh, affected by this water level. In this case, I mean the case 1. Q is what? This part plus this part. Okay, so if you want to find the total Q, because the first part here, in this part we have dry soil. In this case we have what? Saturated soil. Okay, what is total Q here? For the saturated soil, we have, for example, for the dry soil, we have, for example, gamma. For saturated soil, we have gamma S. And what is Q here? Is gamma D plus what? dF minus D dot gamma of this part, gamma saturated. Sorry, gamma submerged. Here, you can see it here. This is the first case. The water level is here. In the first part, we have soil. In the second part, we have water and soil. So, in here we have gamma prime. What was gamma prime? Submerged. Gamma prime is equal to saturated minus water. Okay, let me explain it again. The weight of the soil, Q, above this level, in a normal situation, what was Q? Gamma dF. Gamma dF. But in this case, because we have different levels, different conditions, it's not this anymore. Uh, Q is the first part, gamma dot D1 or D plus this part, what is this? Total dF minus D dot uh, gamma saturated minus gamma water. We call this gamma prime or gamma submerged. Okay, saturated or saturated minus water, or we can show it with gamma prime submerged. Okay, what about this part? This is for Q term. What about gamma term? For the gamma term, because the soil below this one, in here, the soil below this is totally submerged. Okay, so the Q term is the gamma term is for the gamma term. We should use gamma prime. Okay, so for the case 1, if I want to write the capacity, Q, the capacity is, for example, 1.3 CMC plus uh, instead of Q, I write the final value D dot gamma plus df minus d dot gamma prime plus 0.4 dot b dot q prime dot n gamma. Here I forgot n. Okay, this is for the first case. Let's check the second case. In the second case, in the second in the second case, the water is below the foundation, the water level. This is the ground, and this is the water level. Okay, this is B, the width, df. Sorry, I think forgot to mute your voice. And what else are here? This is the distance from. In this case, you can see that in this part there is no water and we have dry soil. So Q is same as before, gamma df. But what about the gamma here? To find the gamma, we need to use this equation. The effective distance of water level is E. What does it mean, the effective level? For example, we have this foundation and this is the water level. Okay, it's obvious. For example, the width of your foundation is, for example, 5 meters, and this distance is 50 meters. It's obvious that because this distance is really long, and this this water level uh, has no effect on the behavior of this foundation. Okay, because here we have a long distance between the water level and the bottom of the foundation. But when, for example, here, suppose that we have the distance of 2.5 meter, or for example 1 meter, this water is close enough to this bottom level and will affect the behavior of this foundation. So this distance is important. What is the threshold? What is the level that the water be less than that level? The water has effect, has influence on this foundation, and below that one, the water has no influence. The level is B. This level is B. Okay, so if D is less than B, you'll have what? The water has influence on foundation. But if C is more than B, no effect on the foundation. So we should provide our equation based on this definition. In this definition, we can see that if you put D equal to B, let me write it again in this way. I told you that in this case, Q is same. Q is same as before. But gamma would be gamma bar. Okay, what is gamma bar? Gamma bar is gamma prime plus d over b gamma minus gamma prime. Okay, I'm gonna explain this equation. In the first case, d is sorry, d is 0. What would happen? Q bar is equal to gamma prime. Gamma bar is equal to gamma prime. Submerged. It's like we have here is filled with water. Suppose that D is equal to B. What would happen? So it's like there is no water below this foundation. Okay, so we provide a linear equation for satisfying these boundaries, and this is that equation. Understood? I'm going to solve an example to make this clear. So that is the case 2, and for this case, I think it's a little complicated now. For the case 2, this is the ground level, and this is the water level. Okay, this is the distance, and the B is the width of foundation. Q is equal to, for example, 1.3 cmc plus Q NQ plus zero point 0.4 B gamma bar and gamma. Okay, what was Q? Because there is no water, nothing is here except soil. So Q is gamma dF. What is this? Q bar. Q bar is Q submerged minus plus E over B gamma minus gamma submerged. Okay, so this is for case 2. What was case 2? D, the distance is between, is less than B. For the case 3, for the case 3, D is more than B. As I said, for example, this is our foundation, and this is the ground level. The water, sorry, this is the water table. Okay, the B is, for example, 5 meter. This distance is 60 meter. It's obvious that this water has no effect on uh, the foundation's behavior. So in this case, Q is gamma df and gamma is equal to gamma. Okay. Any problem? Any question?
So what we wrote that if the little t greater than b, so no effect on the foundation.
What? Can you repeat it again?
We wrote that if t greater than b, it means no effect on the foundation.
Yes.
But now we write the gamma equal to gamma and q is equal to df multiple gamma.
Yes. Let me write it again. In this example, you can see. Okay, in here it says that we have a square foundation. Gamma is 105. Look at the dimension. Look at the unit. Sorry, is pound per cubic feet. And gamma saturated is 118. Phi is 34. Df is 4. D1 is, for example, in this case 2. So df is 4 feet. Gamma is 105. Gamma saturate 118. And phi is 34. Okay. I'll explain three cases. The first one, in the first one, D1 is 2 feet. In the second one, D1 is 5 feet. And in the third case, D1 is, uh, for example, and what would be, and for example, assume that D is 4. In the other case, D1 is 9 feet. Okay, could you please find for each case find Q and gamma bar? Okay, or in each case you can let me say it in this way. Please find Q ultimate for each case. Okay, I'll tell you NC, NQ, and it's in this table. Here, this is what? 5. This one is NC, NQ, and N gamma. So 52, 60, 36, and 38. Please solve this one. And because the foundation is square, use this equation. waiting for your calculation. Okay.
Teacher, gamma water equal to
Oh, sorry. Yes. I forgot to say that. What gamma water. 62.62. Gamma water is 60. Okay. Let's solve it together. For the first case, case 1. For the first one, what is Q? Two
Q equal to plus df minus d multiple
2.1
gamma
2.105 plus 2 dot,
4 minus
or let me write it in this way. For the first case, this part, and this part is same in all cases. Okay, this part is same, this part is same, this part is same. But this one and this one is different. For the first case, Q is equal to 2 because D1 is 2. 2 dot 105, Q is 105, plus 4 minus 2 dot gamma prime. What is gamma prime? Gamma saturate 118 minus 62. Okay. What about gamma for the case 1? Gamma is equal to 118 minus 62 is equal to gamma saturate minus gamma water. This one is equal to D1 that gamma plus df minus d1 dot gamma prime, or gamma saturate minus gamma water. Okay. For the second case, d1 is 5. Okay, d1 is 5. What does it mean? d1 5. That means this is the foundation. This is the ground level, and this is d1, and this is the water table. Okay, this is b equal to 4, and d1 is equal to 5. So df is 4, and lowercase d is 1. Okay, so in this case, what is q? Because there is nothing here except soil, no water, so q is 4 dot gamma, or gamma df is equal to 4.105. What about gamma? In this case, as I said, gamma is equal to gamma prime minus b plus d over b gamma saturate minus gamma prime. So in here, d is 1, b is 4, and you should note that in here d is less than b, or 1 is less than 4, so we are in case 2. So in this case, gamma is equal to gamma prime plus 1 over 4 118 minus, what was gamma prime? Gamma prime first. Gamma prime is 118 minus 62. It's equal to 40, 56. So here, based on this equation, gamma is equal to 56 plus 1 over 4 118 minus 56. In the case 3, in the case, d1 is 9. So for the case 3, d1 is 9. What is d now? 5. This is df, and this distance is 5. So here, for this case, d is equal to 5 more than d is so case 3. In case 3, we can assume that there is no water. So in this case, we can say that Q is equal to gamma D 105.4 and uh, gamma is equal to 105. So you can use this Q and this gamma for each case. Okay, for this case, you should use this one and this one. For this case, you should use this one and this one. For the other case, you should use this one and this one. When you obtain this one, then you can put them in this equation and get your answer. Any question?
Teacher, I didn't understand the last one. Q equal to gamma multiple 0. What it means? The gamma multiple what?
Which one? Case 3?
The last one, 3.
In case 3, no, it's not 0. It's D. DF.
It is DF, yeah?
Yes, it is DF.
DF.
What about now? It's clear now?
Yeah, it's clear.
Okay. So this is the effect of water in a uniform layer. What does it mean, uniform layer? I'm sure that you know it from the soil engineering that, for example, this is the ground level and we have different layers of soil. Okay, we can't find a place, or it's not easy to find a place that all the layers are same. How can we define, or how can we find the layer, the differences between the layers by knowing their C and phi? Okay, for example, in this case, we have C1, Phi1, C2, Phi2. Okay, so depends on these parameters, we can say that this layer is equal to this the other one or not. Also, based on their sieve analysis. If you perform sieve analysis, you can say that, for example, their grading is equal. Anyway, but for our case, we assume for now. In future, we assume different layers. But for now, we assume that all the soil here below this foundation is uniform. That means in each point, okay, at each point, if you check soil at each point, you will get what? C, same C and P. Okay. Let's go for the next part. If you remember, I told you that the first theory is Terzaghi. I explained the Terzaghi and we talked about it. But if you remember, I told you that this is the first one, the first theory. And after this one, many researchers improved this theory by suggesting different factors. For example, here you can see that here we we use different equations for different shape of foundations. For example, for square foundation we use zero point 0.4. For circular foundation we use zero point 0.3. So it's not a general. You can't say that this equation is general for all cases. Okay, but researchers or engineers are looking for the general equation, not for different cases. And also, as I said, these factors NC, NQ, and N gamma are not that precise. So, as I said, researchers studies have conducted to find a general and also a bit better accuracy for finding the capacity of uh, foundation. Here you can see that this is the final equation for shallow foundation. You can see it here. That considers all the cases. Okay, all the cases. I mean, different shapes, different different shapes, different types of loadings, uh, also different ground levels, all of them. You can see that it's uh, not complicated, but it takes time to calculate the capacity. But in many cases, these factors are 1 or are 0. So depends on your case, you can simplify this equation. Anyway, let's see what are they. First one is F stands for factor. Okay, you can see that in each part we have all these words are C. All these subscripts are C. What does it mean? It means these factors are for C term. C term. You can see that this one, all these subscripts are Q, NQ, Q, QS, QD, QI. The other part, you can see all of them are gamma, gamma S, gamma D, gamma I. What are they? What are these factors? If you want to develop a general equation for finding the capacity of a foundation, you should assume different cases. For example, in one case, you have this foundation. This is the simplest one. For example, the shape is rectangle or square. The load is 100% perpendicular to this foundation. This is the load. Also, df, for example. Also, df is very common, not too deep or shallow, whatever. It's everything is normal. So this is the easiest case. But in some cases, you may have, for example, a load like this. For example, if you check complicated architectural shapes, you say that, well, you can say that, for example, this is a structure, and this is a structure, and for example, these are the columns. Okay, in modern buildings, or if you want to construct a very special building, you may face different situations. For example, in this case, you can see that the columns are inclined or are not perpendicular like this. Okay. Also, in some cases, for example, in future, you'll see that. For example, this is a slope. For example, and you want to construct your building near this slope, and you can see that the shape of the ground, because this is the ground surface, but in here you have nothing. So if you remember, I told you that this is the failure surface. You can see that because here we have nothing, the failure surface will be different from the normal cases. In the other case, I told you about inclined. In the other cases, for example, sometimes you have square, sometimes you have rectangle, sometimes you have, for example, this type of foundation. For example, 110, for example. In the other case, you have, for example, 5, 5. In the other case, you have 3, 4. So you should consider the effect of this shape. You should consider the effect of the direction of the load. I explained you in this case, for example, here, this angle. You should consider this effect. You should consider this effect. You should consider the depth. Sometimes it's deep, the other times it may be shallow. So you should consider all of them. And in this equation, you'll see that you can consider these different situations, these different conditions that affect that have effect on the final behavior of the foundation. So let's talk about different subscripts. Here you can see that we have in all the cases we have same S, D, and I. The first one, as I said, the first letter is C. That means for cohesion. This one is for the weight. This one, the weight of the soil above, and this one is for the weight of the soil below. Okay, but you can see that S, Q, and D repeat in each term. Okay, so what is S? S stands for shape. D stands for depth, and I stands for inclination. S factor is shape factor. Okay, that means by using this part, by using this factor, we can consider the effect of shape on cohesion term. By using this one, we can consider the effect of shape on Q term. By consider this factor, we can by using this factor, we can consider the shape on gamma factor. Again, we have same depth, the effect of depth on C term, the effect of depth on Q term, the effect of depth on gamma term. The effect of inclination. What was inclination? This is the inclination. So we can say that this load is perpendicular, but this load is perpendicular, but this load is not perpendicular, or this load is an inclined load. Okay, so we can consider the effect of this inclination by using these factors. The first one, FCI. This term considers the effect of inclination on C term. This one considers the effect of inclination on Q term, and the last one considers the effect of inclination on Q term. Okay, uh, but it takes efforts to find them. But there's no way if you want to design, if you want to consider all conditions and all uh, items on your calculations, you have to do them. If you know how to work with Excel, you can easily write their equations. You can see they are the equations. They are the equations here. Fs, Fqs, well, all of them. You can write these equations for example, an Excel file, and just by importing these factors, you can easily get the factors. If not, or in your exam, you should use your calculator to find it. And again, as I said, Terzaveh suggested the first generation of NQ, NC, and N-gamma. And if you remember, I told you that they are not 100% accurate. So the other researchers, um, here you can see that the basic nature of the failure surface in soil suggested by Terzaveh now appears to have been borne, but have to borne out by laboratory and field. What does it mean? That means they are not based on the studies and experiments. They found out they are not accurate, so they suggested different equations. NQ is this one, NC is this one, and N gamma is this one. If you remember, one of you asked that uh, in uh, in the previous equations we had Q a case, I think gamma KQ, but in here there's no such thing. And again, instead of finding these factors, because you're gonna use it in each question, in each problem, you have to find them. So for simplification, you can use this table. They're same. You just need to find your phi and get your answer. One question, what's the difference between phi prime and phi or c prime and c? Because in all these equations, we have c prime, not c. Do you remember that from soil engineering? Do you have any idea, Ranmali, what's the difference between c and c prime or phi and phi prime? No, what's your idea?
It's maybe like the gamma. It's one of them is the difference between other
Gamma
ones.
prime and gamma. Okay, c prime is effective cohesion. What does it mean? That means if you have water and soil, c prime just considers the soil without the effect of water on it. Okay, I'll continue in the next class because I need to explain it completely. Okay, do you have any questions so far?
Not
Okay, see you next time. And one more thing.
So,
What?
C prime is for without the effect of water.
Yes. C prime anyway, because in soil engineering we are looking for soil, not water. We can't rely on water. So in all our equations, we just consider their prime. It means soil without water. Okay, and for please tell your friends, because one of my students told me that you can access uh, YouTube. So I upload all these videos that I record to my channel, so you can check the videos of each class. So if you were absent in previous classes or the other friends that can't use Teams, Microsoft Teams, please let them know to check my YouTube channel to see the videos of the class. I'll share the link so you can find the video.
okay, teacher. Thanks.